So here we can have quite an interesting analysis. Uh, let's consider a couple of structures. Let's say that you have this cyclohexane, where you have a chlorine that is pointing to you, and you have a methyl group that is pointing away from you here. So what will be the outcome of a reaction of that compound with KOH to give an elimination product? So the question is, are you going to get this product with a double bond here, or are you going to get, and the methyl group there, of course, or are you going to get this other product like that, still with the methyl group as a dash? And so which one should you get? Well, so for that, I need to pay attention to the antiperiplanar relationship of the chlorine with the hydrogen atom that will be abstracted, right? So if I look the chair conformation corresponding to this, what would it be like? So I will have this, and let's say that I have the chlorine pointing up here, right? And because the methyl group is trans with respect to the chlorine, so that means that the methyl group is here, right? Too bad. Too bad, because that means that the chlorine here doesn't have a hydrogen atom as antiperiplanar. The only hydrogen atom on this carbon atom is there, is equatorial. The only way to get an elimination E2 is to have both the chlorine and the hydrogen atom, both of them in axial position. So, conclusion, too bad, I cannot eliminate in that direction, and I will have to look in the other direction, right? And here in the other direction, you can see that I have one other hydrogen atom here, the one that I am circling in red, that is equatorial, and another hydrogen atom there that is axial, right? That is axial. That is good, right? That is good. So I will be able to perform the elimination, and the product that I will obtain will look like this. I will have my double bond there in the back, and the methyl group here is still pointing down here, right? So conclusion, when having that particular starting material, this particular starting material, the product that I will get is not necessarily the more highly substituted alkene. I'm getting an alkene that is di-substituted. Di-substituted. You need to respect the requirement of antiperiplanar between the halogen that is being that is departing as a leaving group and the hydrogen atom that is abstracted by the base, right? And so here you can have the OH, the base, will abstract the green hydrogen that we have there. Then we eliminate that to form the double bond, and then the chlorine departs, right? So that is an interesting example. We can, based on the stereochemistry of the starting material, the relative position of the methyl group and the chlorine, we can figure out which one of the two alternative products is the one that will really form. So the one that really formed was this one, and the one that didn't form was the upper one, right? So this one here didn't form at all. So let's try now another example. Let me insert another slide here to a blank slide there. Okay, so then now let's consider the other possibility, instead of having the chlorine and the methyl group trans to each other, how about if they were cis to each other? So if I have this compound with the chlorine cis to the methyl group, so then what is going to happen there? Now, when I look at my chair conformation, that means that the chlorine is axial there, right? And then the methyl group is equatorial because it's cis. So this CH3 group is cis to the methyl. And of course, that means that there is a hydrogen there. Great. So if I have a hydrogen there, that means that I will have the possibility of having the base abstracting that proton. I will form the double bond there, and the chlorine leaves, and I will have formation of the double bond here, and the methyl group will be there, right? The chlorine is gone, right? Chlorine is totally gone. And that means that the product that I am forming is the more highly substituted alkene. So in this case, when using this particular starting material, I was able to get a tri-substituted alkene. But in the previous example, we were not able to do that. Isn't that interesting? We will see that there is a lot of competition in all these reactions. So when you have an SN1 reaction taking place, inevitably you will have competition between SN1 and E1. And also, depending on the solvent that you use, you can also have competition between E1 and E2. So in the next mini video, we continue analyzing that.